Okay, we'll get started. Before we do, is there any questions about anything? Okay, so just a reminder, we have 2 lectures left. So this week and then next week, and then the week after we won't, because I asked you to do like 2 lectures worth of material online before reading week. So okay, so last class we talked about policies. We used the example of airport policies. We had lots of other policies as well. The next 2 classes will also be about policies, but in this case we're going to focus on technical policies. Okay, so it's the idea of a policy, but it's going to be enforced by a computer. And specifically, we're going to look at 2 policies that exist within browsers. Okay, so browsers, they go back to the 1990s. World Wide Web and Mosaic were like early browsers, and then Netscape was the first, I would consider it, major browser. So the other 2 were kind of fringe projects, like people who were really into the internet back in those days would use them, but it wasn't. Netscape like kind of made the internet mainstream. Okay. Then a year later, Microsoft released Internet Explorer. Microsoft put Internet Explorer in every copy of Windows. Windows was the dominant operating system, still is, I guess. And and then there was some like lawsuits and things like that about like whether Microsoft should be allowed to do that, or are they forcing everyone not to use Netscape and things like that. And they kind of changed it so that when you install Windows, it would give you options to not use Internet Explorer and things like that. Okay. It took Apple a long time, 2003, before they came out with their own browser. Up until then, Netscape is what you would use on a Mac. Then Firefox came out. Firefox was basically a reaction to Internet Explorer. So by the time Firefox came around, Netscape had kind of died. In fact, it might have been discontinued. And Firefox was kind of built from the same technology that underlied Netscape. And the main thing about Firefox is it was supposed to be very, very fast. Internet Explorer by that time got really bloated, and it was really slow and used a lot of memory. I remember that as a search engine, but did they have a browser as well? Okay. Yeah, so Alta Vista was one. There's a couple I didn't include here too, like Opera is another. Opera was even lighter weight than Firefox. Firefox was kind of like actually, Opera, I guess, is down here. And then Google eventually came out with Chrome. And as you can see now, Chrome is like the most popular browser by far. And this is on computers, not mobile. Then Microsoft, then Safari, and then Firefox. Some people still use it. A couple of people use these other ones. Okay, what does this have to do with anything? The 2 policies that we're going to talk about were made by Netscape. So before Netscape, these policies didn't exist. Netscape came in and said, we need some policies around these things. Both of the policies came around the first year of Netscape, so they came in 94 and 95. Internet Explorer copied what Netscape did, and then every browser since then copied what Netscape did. Okay? So basically decisions that Netscape made in the 1990s are still in all browsers today. They're still the decisions. Now it's just how the web works. They are policies, though, in the sense that Netscape did not have to decide to do things the way that they decided. Okay? So they made some decisions. You could imagine other ways that you might do it. And there were consequences that we still feel today, but by now I think, it's been decades. People have sort of got their head around the way things work. But there were consequences to how they chose to do things. So the consequence of their cookie policy is a set of attacks called cross-site request forgeries, and the consequence of how they chose to isolate JavaScript resulted in what are called cross-site scripting attacks. Okay, so we're going to look at those 2 categories of attacks as well. These are attacks you'll also learn in other courses. So I think in 20 or 30, you'll spend a lot of lectures on them. You'll go through the details of how they work mechanically and things like that. My focus here isn't to teach you the attacks. It's more to show you what why those attacks even exist and how it traces back to policies that were implemented. And I'll still give you some examples as well. But our focus in this class is slightly different for why we're looking at those attacks. Okay, so in '94, Netscape invented the concept of a cookie. And we'll talk about what that is. If you don't know what it is, it's fine. And they implemented a policy for how cookies are going to work. And then the next year, they came up with something called the same origin policy. And this sort of governs scripting and how scripting works. And we'll spend next class. So this class, we'll talk about their cookie policy. Next class, we'll talk about the same origin policy. Okay, so this is something we saw already. Well, sort of. We saw pieces of this when we talked about HTTPS, but we'll just go over it. If I download a website, so I'm on whatever, the Wikipedia article for CF Montreal, and I'm looking at it, I see the website itself, and everything that's on the website we call a resource. Okay, so like if there's a little picture, that's a resource. If the text is rendered in a specific font, that font is a resource. Okay, so your website is just sort of a collection of resources. So there's a basic HTML page that kind of defines everything, but then it might pull in other different kinds of resources. Okay, resources can get split into two types. There's the content, which is what you see on the page, and there's the meta content, which is things that your browser tells the website about whatever it wants to tell it about. And it is not reflected in the website itself. It's not in the content of the website. It's just extra information that's sort of being passed between the website, the web server, and your browser. Okay? So meta content could be what website were you on before you clicked the link and now are on the current website. So this is called the referrer. So that's something that you would pass along to the website. And then the server, it can be configured to ignore it, or it might try and do something with it, depending. You might send what browser, like I'm using Safari, and I'm using this version of Safari. You might have a conversation about what fonts you have installed, so it can make decisions about how to render the website. Okay? Cookies, which is what we'll talk about today, is in that meta information. Okay? So cookie is not something that's on the website. It's not like when you look at the website, the cookie's in the content of the website. It's a conversation that's happening between your browser and the web server, but is not actually in the website itself. Then the content itself isn't so much relevant for today for cookies, but next week when we talk about scripting, it will be a little more relevant. Content is usually split by browsers into what's called passive and what's called active content. So passive content is just like, it doesn't execute, you just look at it. So text, HTML, a video, an image, an audio file, that's all passive content. And then active content is anything that could execute or run code. So scripts would be the most common. CSS should actually be kind of like passive content because it just defines the layout of the website. But because so many features have been added to CSS and it's become more powerful over the years, now browsers treat it as if it could be potentially malicious. So they'll isolate it as active content. And then sort of within JavaScript, another example would be like if your JavaScript starts requesting resources. So it says, go to this website and download this image, but that isn't in the HTML of the page, it's in the JavaScript that's running that's making this request. That would be considered active. Okay, so when it comes to browser policies, you're going to have some goals that you want to achieve. And so these are high-level goals that go back to Stride for generally like what browsers care about, not specific to cookies or scripting yet. So the first thing is you can think about tampering. Okay, so the web server is trying to send you a website, and it knows what the website looks like on its servers, and it wants you to experience the same website that it sees. Is there any chance that you end up seeing a different website? Okay, so is there some way that somebody somewhere could tamper with the website and render it so it looks completely different than what was intended by the web server that's serving it up? Okay, so this could be someone in the middle. It could be someone who gets some JavaScript running on the website alongside the website itself. So those are two options that we'll see later. There's a privacy consideration. So the first thing you can think about the wire itself. So like I'm downloading the content. I'm downloading my bank statement from the bank. And so can anyone see that? So HTTPS more or less takes care of that. There's also privacy considerations when a website is composed of more than one thing running on the website. So for example, Wikipedia is giving you a website, but then they have ads from Google. And so can Google see what Wikipedia is showing you? For example, that would be a question that you should ask. Okay, so that's information disclosure. So the two policies that we'll look at, same origin policy actually is, I guess technically it's about both. It kind of concentrates on tampering, but there's a flavor of information disclosure as well. And the cookie policy is really about information disclosure. It's not really about tampering. It's just it's more of a privacy kind of consideration. Okay, all right, so set all this aside. So what are cookies? So let's say I go to Gmail and I want to check my email. So I type in my username, password. It shows me my inbox, right? Then I look at my inbox and I click on the first message that's in my inbox. Do I have to send my username and password again when I look at that first message? No. Okay. So how does Gmail know that I'm the same person that just logged in? Okay, so one option could be it doesn't know. Okay, so it creates a concept of a session, but how does it know that this belongs to the same session as opposed to another session? Ideas, I'm not expecting you to know the answer, it's just how would you do it? Your Gmail, you could imagine a web experience where it's like, you want to see the first message, give me your username, password, I send you the first message. Then you're like, oh, I want to reply. So you type out your email and hit reply, and then they're like, okay, give me your username, password, and then it sends the reply, right? But that's not how the web works. Somehow it like figures out who you are at one point in time, and then it's able to kind of persist or stick or remember that you're the same person coming back.
Can we have like set up a timer to show that this session is running from this time?
Okay, so I can receive the first, so I check the password, it looks okay. I set a timer for 5 minutes.
No, it's not 5 minutes. Until the timer resets, so this session is still going. And when the timer is like it becomes 0 again, so the previous session is now closed. And for setting up another timer, we need to enter our password and username.
Okay, so we could have a timer that times out sessions after a certain point, forcing another authentication. But my question is a little different. It's like before that reset happens, what is a session? Like, let me ask the question a different way. Your Gmail and everyone in this classroom logs in at the same time, okay? And then you all ask for your first message. Am I going to get confused and send like the first message of one of your inboxes to the wrong person? Or like, how do I keep track of like who people are? So IP is a good guess. But the problem is we're all at Concordia, we're all in this classroom. What IP address do we all have? Okay, so just pause on that. So let's start with the IP address. So the IP address, we all probably share an IP address. It is possible to set up networks where you give everyone an individual IP address, but the way Wi-Fi works and NAT routing, usually you can share one IP address amongst multiple people. What about a MAC address? So a MAC address is a unique identifier that's in my computer. So my MAC address is different than your MAC address. Does that work?
Like usernames and passwords exist for this very reason. So why should it get confused and send first messages of each username and password email?
Yep. So let's go through it step by step. So I go to Gmail, I type my username, password in, right? So it knows who I am there. I'm not disputing that. It knows I'm Jeremy Clark. It shows me Jeremy Clark's inbox. Okay? So that's now done. The inbox is now on my computer. But when I click that first message, I send a request back to the server, and I say, show me Jeremy Clark's first message from his inbox. How do they know that that's coming from me, the person who just logged in, and not someone else in the class who's just going to Gmail? Like, you see me on Gmail, you're like, oh, he just put his password in recently, so I'm going to go to Gmail and say, I'm Jeremy Clark, I'm coming from the same IP address. I can spoof the MAC address. So MAC addresses have no security on it, so that's why they don't work. Otherwise, it would be a good solution. And I can look exactly like Jeremy Clark. And I'll just, and Jeremy Clark is actually on his email asking for email, so I'll just say, give me Jeremy Clark's first message. What stops Gmail from sending that to you? Or does it? Okay, so what's a session token? Okay, so there's this concept of a session. So when I log in, it opens a session for me. The session is protected by a token, which is like a random number. But where is the token? Maybe is a better place of putting it. Okay. It's in the cookie, it's in the browser. So can anyone be more specific? Like where do I get it from? Again, you don't have to know the answers. We're just brainstorming. Okay. How does it get into? Well, okay, who creates it? Let's start there. The server creates it. Okay, and then where does it go? Okay, so the server asks my browser to store it. Okay, so then what? Yeah, sure. So wherever, it could be stored in RAM or wherever it stores it. Okay, so there could be other information that's stored as well. Okay, so far we have Google picks a random number and says, store this, which is fine. But when I go back and I ask for the inbox, how does it know I'm me? Okay, so let's say I present it. So I say, oh, here's the value that you sent me. Okay, would you know that value? Anyone else in this room? Okay, so it would be unique to me, right? What if I go to the wrong website and I say, here's my session cookie for Gmail? Could that website then turn around and say, okay, I know your session ID, and then log in as me?
It doesn't have the token in their server.
So, but what if I'm presenting my token, what if I present it to the wrong person?
That person might misuse it.
The person might which? Okay. Yeah, so that's correct, yeah. So they will misuse it. So then what? So how do we prevent that? Okay, you're very close. You basically have it almost nailed down. Okay, let's say it's a short time after. They instantaneously turn around like a man in the middle attack.
It's gonna be stored in the, for example, Gmail server, and it says that whenever a user is trying to log in using this token, we know that this token is expired, and we can't use it anymore.
Okay, let's set aside the whole expiry thing. Just pretend tokens last forever. We'll talk about expiries eventually, but you're sort of getting on the wrong track. So like, how do I show the token? When do I show it? How do I decide to show it? How do I make sure I don't show it to the wrong person?
Should we use like HTTPS for that?
Okay, so HTTPS will protect the cookie. So this is actually mandatory. if you could pull the token out of my connection, like when Gmail sends it to me and you could pull it out, then you have my session token. Yeah? Okay, so it is more or less like how you guys came up with it. So Gmail says, I'm going to give you a unique number. I'm going to pick a random number. I'm going to give it to you. Okay? You're going to store it. Every time you come back to me, you're going to present that number. You're going to show it to me. Okay? And if you show it to me, I'm going to remember in my backend database, I have your username, I have your password, and then I have your current cookie value or your current session ID. And so every time you come back to me, I'm just going to go look up that cookie value, and I'm going to see that it's in my database and it belongs to you. Then I'm happy to show you your inbox, your first message, your second message. Okay? And the final thing we need is a policy so that I don't end up showing it to the wrong website. But that's pretty easy. It can just be based on domain. So my browser will look and say, you're going to www.mail.google.com. Okay? This cookie, you should only show it to that website. You should never show it to any other website. Okay? All right, so I have lots of slides about this, so we'll go over it again, but that's the gist of it. So I go to Gmail, it asks me to log in. I log in with my username and password. It shows me my inbox. I click on the first message. How does it show me the first message without logging in? So it uses a session ID. Okay. I think there's probably slides about this soon, but I'll just say it now while it's fresh in my mind. A cookie is a mechanism for websites to store things in your browser. One thing that it would store in your browser is a session ID. Okay? So a session ID is one kind of cookie. Sometimes we call them session cookies. Okay? So you could use cookies for other things. Cookies help you solve other problems as well. For example, let's say I go to a website and it shows me the French version. And I say, I don't speak French, I want it in English. There's an option for that. It could set a cookie on my computer that basically says, the user wants to see this website in English. Okay? Then I close my browser, I restart my computer, I come back 2 weeks later to the exact same website, and now when I click on it, it shows it me in English. How did it do that? Well, my browser remembered, like the website gave the option to set the cookie, my browser remembered it. When I asked for the website again, the browser said, oh, by the way, that you set this cookie. The browser doesn't know it's about English, it just sees it as some data, but it sends this like blob of data, and the website's like, okay, that's the English preference, and then it shows me the English version. Okay? So cookies have two components. It's like a database. Like there's a tag or a name or a key for it. So it might be like language, and then there's a value. So the value might be 0, it might be 1, it might be a long binary string, it might be the word English, doesn't matter. It's up to the web server themselves. They can set cookies any way that they want. Okay, so the cookie starts at the website. Okay, it's not something you create on your browser. All your browser does is store things that it's given. Okay, so the website can create any number of cookies for you. Okay, and it will send it to you, and it will send it in the meta information of the first packet. So basically, you go to a website for the very first time, you've never been there, you'll say, give me index.html, and the server will say, okay, here's index.html. By the way, here's some cookie values, I want you to remember them. Okay? The browser will store them, and it will also write down who was the website that gave it to me, and it will also do a sort of check. So there's going to be a policy that kicks in that basically says whether it's allowed to store this or not. So you could create cookies. As you'll see, there's like places to put things in cookies that are invalid, that would the browser wouldn't accept. Okay, so the browser does some verification of the cookie. We'll talk about what that is. Then every time you go back to the same website, okay, we need to lock what that means, right? Like, is images.google.com the same website as google.com? I don't know, maybe not, right? So this is where policy decision will kick in again, but it will send it to the same website in the future. Okay, so when does it decide this? How does it decide it and all of that? That's what the policy is for. Okay, so here's the same information sort of visually. So Alice goes to a website like mail.google.com. She sends a request. the website says, okay, I know who Alice is. I have a username for her. I have a password, hash of a password, hopefully, and I have a session ID for Alice. I'm going to create, I'm going to create a session ID for her. And the session IDs, if you can steal a session ID, it's like stealing someone's password almost. It's like you're logged in as them, okay? And so they need to have the same protections as passwords, meaning they shouldn't be able to guess them, okay? So I shouldn't be able to just try random numbers and eventually hit on a cookie that's valid. So they have to be long and random. And then the second thing is you have to pass them around over HTTPS. Otherwise, people in the middle could pull out the cookie values. Yeah, so they're encrypted by they'll be encrypted by the HTTPS. Let me just back up a second. And now that I'm looking at the picture again, I know where I was going with it. I said things slightly wrong. Okay, at this point, I mistakenly said Alice shows up at mail.google.com, but actually what happens here is just some user shows up. Alice hasn't logged in yet, so Gmail actually has no idea that this is Alice, okay? So the entry that it creates is actually this sort of unknown one. So Gmail says, okay, there's a new user, don't know who they are. I'm going to give them a session ID anyway. Why would I do that? Well, it's so I can track them as they move around the website. And then eventually, if they do log in, I know everything they did before they logged in as well, okay? So websites will give you a unique session ID even if you haven't logged in, per se. But at this point, I don't know who this person is, but I'm going to give them this session ID. And then when I respond, I'll send the set cookie in the header, and I'll say, okay, I want you to set this value. You can label it SID for session ID. Okay. Okay, so in terms of encryption, I said this has to go over HTTPS. I also said it was in the header. It wasn't in the content. So we know that HTTPS encrypts the content of websites, but does it encrypt the headers as well? So someone says no. Anyone disagree? So it turns out it does. So it's a good guess that it might not, and it's something you would have to check. But it turns out it does encrypt the headers as well. Okay, so we're safe. So anything that's in the headers is also covered by HTTPS. Basically, the only thing that's not is not at that level of the stack. It's at the IP routing stack, and it would be the IP address of where it's going. So the cookie value would be encrypted if and only if HTTPS is used. I shouldn't say only if HTTPS is used, or whatever else, what other replacements there might be for HTTPS. Headers are covered by HTTPS. Another thing too is I think we talked about this when we talked about attacks on HTTPS. There was this sort of architecture of website where you would log in, you'd send your username password over HTTPS. Once you're logged in, it would switch you back to HTTP. So it would just take your password. The problem with that is you've now switched over to using a cookie, but the cookie value is not going over HTTPS. So even though they took your password over HTTPS, you now have a cookie that keeps you logged in, and someone could steal that cookie. Okay? And if they were able to lift that cookie out, then they could log in as you. All right? They still would know your password, so eventually the cookie would expire. If you do certain types of actions, first off, I should say this is called session hijacking. So if you've heard that term, it's a fancy way of saying I steal your cookie. If I say try to reset your password so I know your password, it might not let you. So most websites understand that the bar to do session attacking is a little lower than stealing a password. And so things like resetting a password, they might ask you to type your password in again, or they'll ask for your old password when you create a new password because they know it's a little easier to steal someone's cookies than to steal their password. But effectively, if I can steal your cookie, it's more or less like I've stolen your password. So people understood in theory that you could, people understood in theory that you could take a username password take it over HTTPS, switch to HTTP, and in theory, attacker could lift that cookie out. Okay. The problem with that is, A, it's a pretty sophisticated attack. You'd have to find the cookie. You'd have to know that it's the session ID. You'd have to pull it out. You'd have to start your own connection, and you would have to insert the session ID into your own connection. And you would have to do all of this being in the middle of the connection, right? You'd have to intercept the traffic before you could even do it. And so websites understood that this was possible, but they basically said, it's too sophisticated, we don't care. We're going to do it anyways, like we're going to switch you back to HTTP because like nobody's going to get in the middle in real life. And even if they could get in the middle, they're not going to know how to like take the cookie out and all of that type of stuff, right? So then someone in the hacker community said, you know what, this actually isn't as hard as it seems. I'm going to build a tool called Firesheep. And this tool is going to be super easy to use. It's going to be an extension. So you don't even have to install anything on your computer. You just go, you download the Firesheep extension, you turn it on, and what it does is it looks to see if you're on Wi-Fi. So let's say you're sitting at Starbucks and it's using public Wi-Fi. The first thing it will do is it will automatically poison the routing table, and it will get everyone routed through you. So now you can see everyone's traffic. And then what it would do is it would know about Twitter, Facebook, and some big social networks. It would know the specifics of those websites. And so it would just say, I know what the cookies look like for those websites. I know where they are. I know how to copy them and things like that. And so what you would do is you would sit down in Starbucks, you would open the extension, wait a couple seconds, and then all of a sudden, if anybody else in the cafe using the Wi-Fi was on Twitter or Facebook at that time, you would see them pop up in the extension, with their username and their profile picture. And then you would just double click on them, and then boom, you're now in their Facebook or in their Twitter, completely logged in. So anyway, so this is a nice example of how you can, people don't really care about things if they're difficult or if it's like, oh, you have to be like a super hacker to do that. But if you can give it in a very usable format, then all of a sudden people really care about it. So when this Firesheep extension came out, it worked. And then people freaked out, right? So it was all over the news and people were talking about it, and don't go into Starbucks, and you can't use Facebook from Starbucks, et cetera, et cetera. And then what happened is Facebook, Twitter, all the major social medias, they switched over to persistent HTTPS. So now everything was over HTTPS, no more switching back to HTTP. So this, basically this Firesheep was, I'd say, one of two major things that pushed the web. Like now HTTPS is used on all sorts of websites, even where you might think you don't need it, like Concordia's website, like their main page or whatever. Basically everything is over HTTPS. Largely this tool pushed a lot of people. And then there was something called the Snowden documents that were leaked that also showed that spy agencies were intercepting traffic. And then that also pushed, those two events sort of pushed most of the web over to HTTPS. Okay, so I send my request. The browser says, I want you to set this cookie. So my browser has something called a cookie jar. And the cookie jar is its local database of all the cookies that websites have asked it to set. And so it will just throw it in the cookie jar. It will say, this website wants to set a cookie. It's called SID. Here's the value. Here's where the website that I was visiting that asked me to set it. And I'm simplifying cookies. In a few slides, I'll show you there's a couple more fields in cookies. They're still pretty simple, but there's like 4 or 5 fields. But anyways, for now, it's sort of like, this is where I got it from, and this is the actual value of the cookie. Websites can set multiple cookies, so there's no limit. They can, Okay. So then what I'll do is, let's say I go back to Gmail. Say now it shows me the login screen. Now I'm about to log in. So I'm sending another request, basically saying, here's my login information. What my browser will do is it will quickly grab that request and it will say, I got to check whether there's anything in the cookie jar that matches where that request is going. Okay, so it will grab it, it will go through the cookie jar, it will say, oh, you're about to send a request to mail.google.com. I see I have a cookie for mail.google.com, so I'm going to put that cookie in the header of your request, and then I'll let the request go. Okay, and so it's going to do that for every request you send. Yeah.
What happens if we have multiple accounts on Gmail?
Okay. Let me answer two questions. First, I thought you were going to say, what if I have multiple cookies? So let me just say it will put all the cookies there. What if you have multiple accounts? So you've logged into Gmail a bunch of times. Then you have multiple cookies, and then Gmail is going to see that you're 5 people at once. So then it's up to Gmail to decide what it's going to do about that. So so it might log you into one of them. It might just force you to log in again with your username and password, like to choose one of them. It might show you multiple profiles, right? So for example, I'll just give you a concrete example. So for sophisticated websites, for example, let's say I go to YouTube, which is run by Google. I actually am logged in to multiple accounts. So I have access to 2 other accounts. So I'm logged into all 3 of these accounts. So I have cookies for all of these 3 accounts. Google knows it, and so it would let me switch between it. But that was a decision Google made. So it's up to the server. So it depends what the server wants to do. So it can let you switch between profiles or accounts, or it can do whatever it wants. But.
So does it mean that they have a copy of our cookie in their server?
Yeah. So if you go back to this to this slide, this database is on the server. So the server says, I have unknown user and I've assigned them this cookie. And this database is with the user, and they have that same value sitting in it. So the cookie, it's just like a password, it's in both places at once. Yeah.
Let's suppose I have 2 accounts, A and B. Sometimes it happens that if I am open with ChatGPT, I am in the account, Gmail account A, but ChatGPT gets on the account B in the same browser.
Yeah.
So how to please log in there?
Okay, so when you log into account A in the first place, it would set a cookie. Okay? Then let's say you log into account B. Okay? Then first off, it might say you're already logged in site A, so I'm not going to let you log into 2. Right? Or it might accept both of them. So this is like how the server wants to implement what it does server side. So the browser and the cookie policy doesn't say anything about that case. It's purely a server decision, right? Or maybe the server doesn't think about it. They just code it up and then now they're confused because there's 2 cookies and then it behaves erratically. So the way that ChatGPT handles that case would be different than Google or whatever, but it was their decision how to do it. Yeah. So the only thing the browser would do is it's just going to send all the cookies that are there, which could include multiple session IDs. Another small technical thing that's relevant is it will only store, it can store multiple cookies for the website, but only one for this particular key value. So it couldn't have 2 cookies with the same key. If you try and set a cookie and that key already exists, it will overwrite the existing cookie with the new value. Okay, and you can't delete cookies either. The server can't delete a cookie. Server could blank out a cookie, so it could just set it to nothing, to an empty string, but it can't actually delete it. You as a user could delete it. We'll get to that in a second. Okay, other questions about how the cookies work? Yeah.
Let's say, for example, in the first time we log into our account and we have this session ID. So if we go back to that website again, for example, Gmail, the session ID will be the same or it will be changed and override?
Okay, so let's say that I go through these 3 flows. I turn my computer off. I never go back to Gmail for a week. And then today I go back to Gmail. What will happen is my browser will say, oh, you're about to go to Gmail. Let me check my cookie jar real quick. It will still see that this cookie's sitting there. It will still attach it. And then Gmail will say, oh, I don't know, at this point in this scenario, I don't know who you are, but I know you're that person that came to me last week. Yeah. So again, it's up to the server to decide how much tracking it does per cookie, but you will go back to the server with that same cookie. Yeah. Now you might say, eventually we'll get there, but you might say, I don't like all that tracking. I wish all my cookies would disappear every time I close my browser. And so you can set that if you want. So that's a setting. It's not the default setting, but if you want, you could set it. And the server can also choose that too. So the server can say, I'm going to give you a cookie, but when your browser resets, like when you close it and reopen, I'm going to tell the browser to delete the cookie. So that's part of the control that the server has as well. Okay, other questions? Okay, let's say then eventually I log in. So I say, I'm Alice, here's my password. Because I'm sending my password to mail.google.com and I have a cookie for it, it would send that cookie as well. And now when the server goes, it says, okay, now I know who this person is. This is Alice. Okay, and so it can replace unknown with Alice and know that it's the same Alice user. Could a user have more than one session ID at a server? So it could overwrite it. So again, this depends on the server. So the server can decide what to do. So it could just overwrite this previous session ID with the new one. Why would it not overwrite it? Just create another entry. Okay. Okay, that's not the answer I was looking for, but let me ask you a slightly different question. I'm on my laptop, I go to mail.google.com, I log in, I get a session ID, all that's good, okay? Then I pick up my phone and I go to gmail.com. Does it know who I am?
Because you don't have the same cookie on your laptop.
Okay. So cookies are local to the computer, to the browser it is. What if I'm like browsing Safari, I log into Gmail, I have a session cookie, then I go over to Brave and I go to Gmail. Does it know who I am? It doesn't, okay? So the cookie values, the cookie jar is in the browser itself. So if you use a different browser on the same computer, or you use the same browser on a different computer, or a different browser on a different computer, you have a completely different set of cookies, okay? So the reason why users would probably have multiple session IDs is because they're using that website from multiple devices. Okay, so one of these cookies is for their laptop, one of them's for their phone, and that type of thing. And the server could probably figure it out because it can just ask what's the user agent and say, oh, that's Safari for iOS as opposed to Mac OS or whatever. Okay, what control do you have over cookies? So as we said, this is on your browser. You don't see this. No one knows exactly what Gmail's database looks like. Okay, I'm just sort of guessing at probably what it looks like. Okay, and I can't control anything here, I think. There are things like I can log out or I can say keep me logged in, and there's a couple things like that. So we should think about those things and what that means for control. But for now, we'll concentrate just on the user side. The user side cookies I do control fully. Okay, so I can do whatever I want here. Okay, so in theory, I can do literally whatever I want. Like I could go in the cookie jar and change values or whatever I want. But there's also the limitation of what does the user interface let you do? Okay, so like if you know how to do it at a technical level, you can do whatever you want. But then there's also like what could I actually do through the user interface of the browser? Okay, so first off, I can block all cookies. Okay, so that's an option. So I can just say, you know what, I don't want any of these cookies. I'm just going to block them. Then I have a problem because if I go to Gmail and I log in, then Gmail doesn't know who I am. Then it's asking for a password every single time I try and do something, okay? So a lot of the functionality of the web breaks, but if you wanted to, you could turn cookies off. You can turn off what are called third-party cookies, okay? So we'll get into this, but what if, for example, I'm on Gmail, but there's like ads from Facebook, and Facebook's trying to set a cookie, but I'm actually on Gmail. So there's going to be some complications around because websites are sort of weaved together from multiple sources. So don't worry, we're going to have a bunch of slides about that. You can clear your cookies at any time. So you can say, I'll keep cookies, but today I just want a fresh start. So I'm going to go in, I'm going to clear my cookies. Then you're effectively logged out of every website. But then as you log into them again, then you'll build up your cookies again. You can tell your browser every time I close the browser, I want you to clear them. So you can manually go in and just say clear them right now. Or you can say every time I close my browser, clear all the cookies and then give me a new one. Another thing you can do is you can use private browsing mode. So you've probably heard of it, maybe used it. What exactly is private, at technical level, what is private browsing mode? How's it different than normal browsing mode? What it is it's just a new browser with no cookies. Okay, that's what it is. Okay, so you have, so it creates a new window for you. Any of the cookies that exist in your normal browsing mode, it does not copy over. So it's just like you have a fresh, empty cookie jar. As you use private browsing mode, it will store the cookies that you accumulate in the private browsing. But then once you close it, then it will delete them all. Okay? But it doesn't delete your cookies in your main session. So once you leave private browsing mode, you go back to normal mode, all your cookies are still there. Okay? So it's kind of like if I don't want my cookies, I don't want to delete them because I don't want to get signed out of all my websites. But for the next 5 minutes, I want it to be as if I deleted my cookies. Then you could use private browsing mode, and then you can go back. Cookies expire eventually, but the person who chooses when they expire is the website. Okay, so the website will tell the browser how long to persist it, and then it will eventually expire. But as you'll see, they could make the expiration in 50 years if they wanted to. Another way you can have extra control over the cookies, hopefully you've thought about this now, is you could use a browser extension like Ghostery or the EFF one, okay, Privacy Badger. So these should show you what your cookies are, and you can do finer grained things, and it will give you an interface, and you can see how many cookies you're collecting and things like that. Now the server can do whatever it wants server side. Okay, it could delete its database of cookies, but you have no way of seeing it. You don't know what they're storing or what. You know what they ask you to store, but you don't know what their database looks like. So if you log out, you don't know that they're deleting the cookie. They might keep it anyways. And every time you come back, they're like, I know you're logged out, so I'm going to treat you like you're logged out, but I know who you are. I know you're Jeremy Clark, right? I'm presenting a website to you as if I don't know who you are, like you're just some logged out user, but I do know who you are because you're still giving me this cookie that was you before you asked to log out, okay? And then if you uncheck keep me logged in, same thing. So it's just on the server side, they'll say, well, they might change how this cookie is stored. So they might change it to like expire on close as opposed to just expire in 30 years. So anyways, but it's up to the server. That box doesn't mean anything. Like there's no technical, it's not like a browser standard what that is. It's just something the website presents to you. You can click it or not. And what that means is what the server decides it means. Okay, so what do cookies look like? So yeah, anyways, if you want to go to a website, so TSN is a good one because it's pretty noisy in terms of other things. You can just use inspect element, which is in, I think, all browsers now. You might have to turn on developer tools to be able to see it. And if I go into storage, it will show me all the cookies that are coming down with this website. So you can see lots of different websites are trying to set cookies. And if I click on TSN, these are all the cookies that TSN is storing. Okay, so you can see it's maybe more than you're thinking. I don't know. It's not like there's just one session ID. There's a whole bunch of cookies about different things. Okay. Now, other websites are also trying to set cookies. That's because these websites have JavaScript or resources. Like some of these images are coming from their servers, or there's some JavaScript running on this. I don't know why, but for whatever reason, it could be ads or tracking or things like that. They also want to set cookies and have the cookies relayed back to them. Now you can see that actually when I go on TSN, there's lots of cookies. And when I go on to any other website, there's no cookies. Okay. Why is that? That's because browsers have changed their default privacy policies. So right now, I'm using Safari out of the box, and it has some privacy policies that are trying to protect third parties. So I'm on tsn.ca, but this is a cookie for Google API, which is not tsn.ca. So it's blocking it from setting cookies or tracking me on this particular website. If I want to turn that off, I can do that. So I'm going to turn off website tracking, prevent cross-site tracking. And I think that's probably the only setting I need to change. I'll reload the website. Okay, so now sometimes it takes a bit of time too. But you can see that in some of these other websites that are not TSN, like DoubleClick, which is a known ad library tracker, that now that there are cookies that are being passed between my browser and my website. Okay, so DoubleClick knows that I'm on TSN right now. Amazon knows that I'm on TSN right now. Yeah, whatever. Okay, now let's talk about the cookie values themselves. So you see that there's a couple things here. I'll go back to the slides because I kind of have it highlighted in the slides. Okay, so here I have the list of the domains that are kind of weaved together with that website that I loaded over TSN. The cookie itself consists of a name or a key or a name. So this is the name of the cookie itself. Okay, so TSN, www.tsn.ca wants to set a cookie, and it's going to call it _SCTR or _SCID. Okay, so that's, again, the server can choose it, and then when it comes back to the server, it will know what that cookie is. There's the actual value that's being sent. And so if you just use your eyes and look at these values, you can see some of them look like computer numbers, like integer, like hex numbers or things like that, like something that would be parsed by a computer. Some of them might be random numbers, but then some of them look like English, right? Like this says true, or this looks like some sort of like parameter list that would be on the end of a URL, like SSL, SL equals 1, SS equals whatever. Okay, this, you can see some JSON, success, : true. So you can store whatever value you want. The server's choosing that. Sometimes it's going to store something that computer code's meant to read. Sometimes it's going to store things that humans are meant to read. Totally up to it. Okay, the next thing it will do is it will set a domain. And the domain basically says, when should the browser send this website, this cookie back? Of all the websites that you're going to go to in the next year, when should this cookie be included and when should it not be included? Okay, so the website has some control over that. Okay, now we'll go through the semantics of it in a slide. So I'm just going to put a pause in that, but that's what it means here. Actually, okay, so there's a bit of information and then I'll show it to you there. So I'm on the website www.tsn.ca. That's the website that's asking me to set the cookie. So I could say I only want that cookie to come back when the user's going exactly to www.tsn.ca. Okay, so that's allowed. You could say send it back to anything.tsn.ca. Okay, maybe not www. Like if it goes to images.tsn.ca or scripts.tsn.ca, bring that cookie back as well. So for any tsn.ca domain or subdomain, including the parent domain, send that cookie back, okay? This is probably a mistake, but semantically it means any subdomain of www.tsn.ca, inclusive of www.tsn.ca. So that would be like I don't know, images.www.tsn.ca. So again, that probably is a developer mistake. They probably either didn't mean to include the www or they didn't mean to include the dot. But anyways, a dot before it means kind of like a wild card, so anything that fits. So these are options. Now, tsn.ca can't set a cookie for and say send it back every time the user goes to google.com. Okay, so it can't set a cookie for a completely different domain that doesn't belong to it. Okay, so that's actually what a third-party cookie is in a technical sense. So maybe I should correct myself. Maybe it could set it, but your browser is probably not going to let it set a cookie like that. Another thing you can do is you can say, only return this cookie if not only are they at exactly www.tsn.ca, but they're at www.tsn.ca/news/whatever//. Okay, so you can put a path there, and then the cookie's only going to come back, not just when the user's going to that domain, but they're going to that specific resource or that path on it. This is never used, so I've never seen it used ever, but it could technically be used. The next thing you can do is put in an expiration date. Okay, so the browser will stop sending it after a particular date. Okay, now this slide is old. I made it a couple years ago. So these dates look like current or even in the past. But anyways, they're setting the cookies usually for 4 or 5 years. I forget when I made this slide. Some of them say session. So session means that when the browser closes, don't send it. Okay, so the browser, it will remember it for that session. Once you close the browser, then it won't send it again. Otherwise, it will wait for the date to pass. Then you have the size of the cookie. So the size of the cookie is more or less the amount of data here. So you can see if it's called PVV, that's a short key. You're only storing the number 1. It's 4 bytes because it's a pretty small cookie. Here I didn't stretch the whole value field, but you can see some of these look like pretty long. And so like this one has a super long name, and it looks like it has a super long value too, and so it ends up being a bigger cookie. Then you have a couple security flags. So we'll talk about 2 of them in this class. One's called secure, and one's called HTTP only. Secure says only send this cookie back if the user is going over HTTPS. If they're going over HTTP, don't include it. Okay, so this is something you might set on like a session ID. Okay, so if the user ever tries to come back to the website, they're coming over HTTP, don't throw the cookie in, because then somebody that's in the middle could grab that cookie off the wire. The other one sounds like it's actually the first one. It's called HTTP only. Actually, it sounds like the opposite. Like I would only send the cookie over HTTP as opposed to HTTPS. But here the as opposed it's not HTTP as opposed to HTTPS. It's HTTP as opposed to a connection that's initiated by JavaScript. Okay? So what this flag says is it says if the user's loading this because the HTML document is saying to load this resource, and it doesn't matter if it's over HTTP or HTTPS as far as this flag is concerned, this flag, it might, or it would depend, then it's fine. But if the user loaded JavaScript and the JavaScript is asking you to go visit this website, don't throw this cookie in, okay? And so the reason why these flags exist is because there's this very specific attack called cross-site request forgery that we'll see in a bit. And it's meant to sort of more or less combat that attack. Okay, and then as I showed you, you have some settings in your browser, and if you, for example, turn that off, then you would see like lots of cookies for lots of third-party sites. And sometimes there's even more websites that try and, once you get that setting off, then you start sending cookies to third parties. The third parties are like, oh, that person's setting is off because I'm getting this cookie, otherwise I wouldn't. So let me like load a bunch more stuff, over JavaScript now that I see that their cookies are off. And so the number of resources could increase as well. Okay, then the next thing we'll do is we'll just sort of go through the semantics of that field, this field here, so the .tsn.ca, and think about who's allowed to set what cookies and when do they go back. It looks a lot like, actually, yeah, maybe we didn't have the equivalent in HTTPS. But yeah, we'll see this today, and we'll see it next week as well in the Java policy because it has a very similar thing. Okay, the basic, just in terms of terminology, if I'm going to a website and it's sending a set cookie header, okay, I call that website the origin. Okay, that's the origin of this cookie. This cookie has a certain origin. It came from this website, meaning this was the website, the exact website that was trying to set the cookie. Okay, and in general, what my browser will do is it will only send cookies back to the same origin. Okay, so if it's a different origin, it's not going to send it. If it's the same origin, it will send it. And if it's a sort of related origin, like a subdomain of the origin that set it, then it may or may not send it. It's actually going to ask the server what the server wants to do. Okay, so the server is going to tell it what it wants to do. Okay, so let's say that the website I'm going to, or the resource that I'm loading is encs.concordia.ca. All right, what this website can do, what can they put in their cookie? Okay. They're allowed to put the exact same domain in the cookie. Then the cookie will always be sent when I go to that exact domain. If I go to images.concordia.ca, it does not match encs.concordia.ca, so the cookie will not go. If I go to concordia.ca, it doesn't match encs.concordia.ca, so the cookie is not going to go. If I go to some completely other website like canada.ca, it's not going to go either. Okay, so the cookie will only, a cookie that sets this domain will only go in the future when the user goes to this exact domain. Does that make sense? Okay, now let's say I do want it to go to some of those subdomains. Okay, what I can do is I can set the domain to encs.ca and any subdomain of encs.ca. The way I do is I just put a little dot in front of encs.ca. Okay, so now if the user is going to encs.concordia, images.encs.concordia, the cookie goes. If they're going to just Concordia, that's a super domain, it's not going to go. If they go to a different subdomain, not a subdomain of ENCS, but a subdomain of Concordia, then it won't go. So it's not going to go to images.concordia.ca, and it won't go to any completely different domain. Now, what if I do want it? I want to set my cookie from encs.concordia.ca, and I do want it to go to any concordia.ca images. I don't care. As long as it's Concordia, just send the cookie. Okay? So what I can do is I can ask for it to be set at a super domain of me. So I'm encs.concordia.ca. I can say, make this cookie bigger than me. Okay? Make it for all of concordia.ca and subdomains, of which I'm a member. And the browser will say, that's fine. You're allowed to do that. So the cookie policy of the browser says that's an okay cookie to set. And then it will send it to basically any concordia.ca. So this is probably the most common thing that you see. The reason you see it isn't necessarily because the developer wanted it. It's because they were troubleshooting and there was some cookie and they couldn't get access to it because they were trying to access it from a different subdomain than what it was set for. Right? And if you go on Stack Exchange and you're like, I can't see my cookies, they're like, well, make them all like at the super domain, right? Like make the cookie as high as possible so that it's seen by the most things possible. So the only kind of website that this wouldn't get sent to is just a completely different domain. Okay? Now, what if I really wanted to set a cookie that would get sent to concordia.ca and would also go to canada.ca? Can I do that? Okay, so what I could try to do is set my domain to any.ca. Okay, but now the browser will say, no, we're not doing that. Okay, that's crazy. There's no practical reason for you to do that. Plus, we're going to be stapling this cookie into like every single website. It's inefficient for us. We're not going to let you do that. Okay, so this would be denied by the browser policy. Now, what if I'm Concordia.ca and I want to make a cookie for Canada.ca? So what that means is I'll send the set cookie. Your browser will store it, but then I'll never see it again because when your browser comes back to me, I'm not Canada.ca. So I'm basically setting a cookie on behalf of another website. But then when you start going to Canada.ca, then that cookie that I set, that I chose, would go along with it. Okay? Why is this a bad idea? The reason it's a bad idea actually goes back to what I said earlier, which is that if you can't delete a cookie, but you can overwrite it. Okay? So what I could do is I could overwrite Canada.ca's cookies. If I knew what the keys were, I could write my own values into it. And so in general, we don't want that. So it's not allowed. Okay. Now, the other thing you can do is you can set a domain and a path. Okay, so again, you never see it, but it's technically there. So I could say, I'm encs.concordia.ca. I want you to return this cookie every time the user goes to encs.concordia.ca, but it has to be at /Clark. Okay, if it's at /Manon, don't send the cookie. Whoops. Okay, so again, you can restrict it by path, but in general, it's not used. Okay, so here's a sort of final kind of thing, and then we'll get into some of the attacks that are possible because of the policy. So I go to tsn.ca, I send a request to it, and I get back. This is the response. So I requested it earlier, and then now I get the response back. And what will happen is tsn.ca will instruct me, if you want to look at this website, that's fine, but there's this image, and it's coming from google.com, and there's this JavaScript widget that's coming from Snapchat, and we do tracking, user tracking with DoubleClick, and we have like a follow me button that Twitter puts in with JavaScript, okay? So I want you to go load all of these resources from all these other websites. When you get those resources, weave it all together and show it to the user. So the user just sees a website, it says tsn.ca on top, but actually it was populated not just by TSN, but it was populated by a bunch of different websites, okay? Now when these requests go out, okay, your browser is going to check the cookie jar for every single one of them. Okay, so it's going to say, oh, I see you're about to send a request to google.com. Do you have any cookies that match google.com? Okay, so they would have had to be set by google.com. They would have to have google.com or .google.com or something like that. If it finds the cookie, it will drop it in. Okay, so even though I'm going to tsn.ca, because I'm asking for at least one thing on that website from Google, then I'm also opening a connection to Google, and all my cookies for Google are going to Google. Okay, so Google knows who I am. Maybe I don't have cookies for Snapchat or DoubleCheck. That's fine. The connections go through without a cookie, and I do have a cookie that matches Twitter. Okay. So your browser is basically looking through the cookie jar. They're asking 3 questions. Where the user's going, does it match any of the cookies in my cookie jar? Is it expired? If it's expired, then it will delete it. If it's not expired, then it will send it. And then it will check the flags as well. So is it set to secure, but the user's going over HTTP instead of HTTPS, then maybe I don't include it. Okay? If it passes all these checks, then the cookie gets dropped in and it gets sent. Okay, questions about this? Okay, there's this video that I made for Concordia that explains cookies, but because the sound in the room doesn't work, I'm not going to play it. Most classrooms have an audio cable, This one doesn't. I tried to show you some videos earlier. But anyways, you can always go to the slides and watch it. It's just a fun sort of example. It's not like technical at all. It's meant for a general audience. I can just sort of say what's happening. Actually, there's subtitles, even better. Okay, maybe you can just watch it and read the subtitles. Okay, I know that wasn't as pleasant of an experience as listening to it, but the point of this is that cookies can be used to track you across different websites. So let's say that I go to lululemon.com. I'm looking at this particular shirt. Lululemon knows, it can set a cookie, okay, so it can know who I am. And because it's running the web server, it even knows that if that shirt is on its own unique website, right, its own unique URL, it knows I'm visiting that URL, so it knows I'm looking at that exact shirt. Okay. Then what would happen is I might bounce over to some third-party tracking website, and because Lululemon's sending me there, and it's sending me, it's setting the URL that I'm requesting from that website, it can pack that URL with whatever it wants. Okay, so it can say, go over to agile.one.com and ask for some JavaScript, but also pass the parameter item 9483. Okay, so that's Lululemon's way of sort of using me to tell this third party, like, I'm looking at this shirt and this shirt is item 9483. Okay, so this assumes that there's a pre-existing relationship between Lululemon and their tracking service. And so the tracking service knows how things are being passed to it. Okay, so then what the tracking service will do is it will set a cookie for me, and it will remember, oh, the person I gave cookie 55, they were looking at this shirt 9483 from lululemon.com. Okay, so they just remember that, whatever. Then I go over and I'm reading the news. I'm on CBC, and CBC happens to use the same ad agency. Okay, so CBC says, hey, go load an ad from agile1.com, their choice. I don't care. Like that's why they're our ad library. We're not telling them what ads to show you. They can choose whatever they want to show you. Okay, and so Agile 1, you'll make the request for ad.js, and before you send that request, you're going to check your cookie jar real quick. What are you going to see in your cookie jar? You're going to see, oh, I have a cookie for Agile.1. It's UID equals 55. So I'm just going to toss that into my request. Okay? So now what does Agile 1 know? Agile 1 knows this person on CBC is user 55. I've seen them before, right? The last time I saw them, they were on Lululemon, and they were looking at this exact shirt. So guess what ad I'm going to show them? I can show them any ad I want. CBC's paying me to show ads. My only goal is to get you to click on something, right? What can I show you that you might click on? Well, how about that exact same that exact shirt that you were looking at before? Okay? And so then you'll get like some sort of ad that basically is it's not just a Lululemon ad, so it could be that too. It might be like you're on car websites, then you go to CBC and all of a sudden you're showing Volkswagen ads because you were looking at Volkswagen cars. But sometimes it's down to the specific product. Like it will show you the exact product that you were looking at. Okay? So how does that work? How did CBC show me the ad of the exact shirt I was looking at Lululemon.com? First off, it has nothing to do with CBC. Okay, they don't know that I was on Lululemon. Okay, they just outsourced their ads to an advertiser, and Lululemon says we pay that advertiser to show our ads on websites like CBC. Okay, so that ad agency is the sort of common link between two different companies, and they're tracking you using cookies, so they know what you're looking at on one website or that you've gone to that website. They're serving up ads on other websites, and they can track you across all the websites that use their ad agency, okay? And then in the video, you might have caught that this is sort of an old video now. I'm not sure what the current numbers are, but at the time it was made, like something like 80% of websites use some sort of resource from Google. So Google can more or less track you across 80% of websites, okay? And a lot of websites voluntarily do that because they want their users to be tracked. I want to be able to log into Google Webmaster Tools, and Google's going to show me, oh, like these are the users that we know about. You know, these many are in Canada, and they're in this age bracket, and you know, these were the search terms that they were searching on Google when they landed on your website. All that kind of information they can show. Okay, so questions about this? Okay, good. All right, let's take a 10-minute break, and then, oh yeah, one more. So no, it's not. It's independent of the browser infrastructure. So the only thing that you require from the browser is just the ability to store cookies, and maybe the like settings, the default settings. So different browsers might have different default settings. Yeah. Okay, so let's pull this apart. So let's say I have two browsers. I have Chrome and Safari. Say on different, I have one on my iPad, I have one on my phone or whatever. So not even the same device. And maybe one I use at school and one I use at home. So like different IP addresses, all that type of stuff. So by default, out of the box, it wouldn't be able to track you because the cookies are local to your browser. So it's only going to cough back the browsers the cookies that were set in the browser. So in order to track you across devices, it would have to somehow link those two cookies together. So the way that Google would do it is once you log in. So once you log in on both devices, it will say, okay, I had these two cookies. I thought they were two different people, but now I see that they belong to the same person. So actually everything that this person was doing with this other cookie, I can now copy over to their profile. I know who they are. Yeah. So that would be more or less how that would be how it could track you between two browsers. So it is possible, but it would require some action on your behalf to let them link them together. Okay, so come back in 10 minutes and we'll go through the rest. Okay, so before the break, we talked about how websites can track you, or how a ad agency or some common website could track you across different independent websites. So all of this infrastructure is in place for a couple of reasons. So the positive of cookies is it lets you stay logged in. You're not typing your username and password in every time you go to a website. So that's handy. If you ever gotten a new computer and had to log in again to every website, you realize that's annoying. Okay? So cookies are good. Cookies remember things like your language preferences and things like that. Okay? The flip side of cookies are tracking. So they can track you across websites. And the other is that they can be a source of attacks. So there's certain attacks that you can do because cookies are there, and you might not think about these attacks as a developer of a website, and so you might leave your websites vulnerable to attack. Okay? So the biggest category of attack is called cross-site requests. The biggest category of attack is called cross-site request forgeries. Okay? Which is a mouthful. And it's basically a forgery, which is the bad thing. Okay, a forgery is a bad thing. It's a forgery of a cross-site request. Cross-site requests themselves are not bad. They're actually good. Okay, they're a feature and they let you do lots of different things. But when you're able to forge them, then they become bad. Okay, so first we'll talk about what cross-site requests are, and then we'll look at how it leads to an attack. So we've already seen cross-site requests, but I'll just show it to you again with this term in place. So again, we're in this world where we're weaving together a website from multiple sources. So let's say I go to CBC, and CBC has some ads or like a like button on the end of their article. So I scroll to the bottom of the article, there's a like button, I can click on it, and what it will do if I click on it is it will go to Facebook and it will say, you know, this person liked this article. It might post it to my timeline or whatever they call it, okay? Another thing that you might see is you might go on the website, you're on CBC, you scroll down to the bottom, and it says 3 of your friends like this article, okay? Now, did it just make that number up? Or is it actually like literally 3 of your friends? And how did CBC figure out, like, did Facebook tell it? Oh, go tell this user that 3 of their CBC's like, oh, this user's looking at this article, and Facebook's like, well, 3 of their friends like it, make sure you tell them. Okay, so how does this all work? So the answer is it is sort of more or less like that, but things are getting passed around because of cookies. Okay, so what happens is, let's say I click on that like button. My request is no longer going to CBC. I'm on CBC's website, but I'm running JavaScript, and the JavaScript is saying send a packet or a message or request to facebook.com. Okay, so that request is outbound to facebook.com. So when my browser looks at it, just like in the previous picture, well, maybe going back a couple pictures. So here, all the cookies for all the different sub-resources that are loaded get loaded in. Okay, so the same thing's going to happen here. It's going to say, oh, I see that you're going to facebook.com. Let me check my cookie jar real quick. I see that Facebook has asked me, the browser, to send UID equals 55 to every packet that you send back to facebook.com, you the user, okay? This is a packet that you're sending to facebook.com, okay? The fact that CBC is asking you to do it doesn't mean anything, okay? The browser doesn't care about that. It just sees that this is a packet that's going to facebook.com. I should throw in all the cookies that belong to facebook.com. So it throws in your user ID to it. Facebook receives it. It looks at the header and says, oh, I know who this person is. I know that this is Alice because she's showing me user ID 55. In reality, it'll be a big, long password-looking number, and Facebook will have a database of all those numbers and which users it assigned it to. Okay, then it will send you back the JavaScript for the like button. And at this point, because it knows who you are, it can package in with that, like the JavaScript that displays that like button, it can throw in whatever data it wants. So it can throw in the 3 of your friends like this article, Okay. Now, 3 of your friends like this article. It does require one extra thing, which is when CBC asks your browser to load this or request this JavaScript from Facebook, it has to throw the article number into this URL. Otherwise, Facebook doesn't know. It just sees that you're coming to Facebook asking for the like button. It doesn't know that you're on CBC. Maybe it can follow it through refer headers or something like that, but it doesn't know what article you're looking at or things like that. So generally, CBC would toss that in with the like button. Then it can show you a personalized website for this particular page. Okay, and then if you click the like button, again, that action goes to Facebook. You're logged into Facebook because you have your cookies are being sent to Facebook. So Facebook knows it's you that pressed that like button. So that's why it can take that article and post it on your profile, and it knows that you took that action itself. Okay, so this is called a cross-site request. It's cross-site because the website I'm on is cbc.ca, but I'm pressing the like button and I'm making that request to facebook.com. Okay, is this clear? Yeah? Okay, all right. Now, forget about this for a second. I'm going to talk about something else. We've already seen it a few slides ago, but I just want to be explicit about it. And then we're going to put 2 pieces together. Okay, let's say that let's say you see a URL like this. You get an email from me, and I put this URL in. What happens when you click on this URL? Your best guess, just looking at what it looks like. So, okay, first, where's this going? Okay. So this is going to go to Google, the search engine, and you can see that my search query soccer is in the URL. And so it's not going to just show me Google and say, what do you want to search for? It's going to jump directly to the search terms for Google, on Google for soccer, and it might flip from, instead of showing me pages, the first 10 results, it might show me the second 10 results, or the 100th results, because I'm on the 10th page of results. Okay? So this idea of putting these strings on the end of URLs is called RESTful architecture, or REST. And why do websites do this? So you've probably seen this everywhere, because basically all websites work this way. But why? What's the reason for this? If anyone knows. Okay, so the reason that Google does this is they, let me, whoops, I'm just going to try and go to this URL. Okay, Safari's aware of Google, and so if I search something for Google, it won't actually show the URL. I think we can try it, but it will just continue to persist to show the search term itself. But we can go to some search engine that nobody ever uses, right? And then it will. Then Safari will show me the actual URL. So you can see it works the same way. So Q here means query. CF Montreal, and then there's a bunch of other junk there. Okay, why does it do this? Okay, yeah. Of the which? I'm not understanding the word that you're saying. Just spell it. The S search engine optimization. No. But it's a good guess. But no, that's more like I want to get my results high on the search results, so I do some stuff to make it friendly for Google's crawlers to find. Yeah. Or I find lots of other websites, and I make fake websites that link to my website, so it thinks I'm super popular, even though I'm not. Yeah. Okay, let's say I go down here and I click next. Okay, previously, a second ago, I was on the first page of results. I click next. Now I'm on the second page of results. Okay? How does Google know to send me the second page of results? I clicked on the second page of results. How does it know that that's what it's supposed to send to me? Okay, there's two ways you could implement it. The old-fashioned way would be you'd use cookies so you know it's me coming back again, right? And it would remember, oh, I have this user, I gave them this cookie, they're currently looking at search results for CF Montreal, they're currently on the first page, okay? Then the request that I send to Google just says, show me the second page. Then they go in their database, they're like, the second page of what? Oh, they were on CF Montreal, they were on the first page. Okay, I'm going to show them the second page of results, okay? This is fine. You can implement a website this way. The only problem with it is you're storing a lot of data about users. Basically, every user that's connected to you, you have to keep track of where they're at, okay? So we call this stateful because you have the state of the user, the current state, what website they're looking at, all of that type of stuff. You're storing that server side. And then depending on the actions that they're taking, you're looking at the state and then you're deciding what to do next, okay? The idea of RESTful is why don't you take the state and just put it in the URL? So when I download this website, okay, and there's this link to page 2 here, all right? In the HTML, I haven't clicked on this, but, okay, let me ask, when I click on this, I go to some link, right? Who chose what link I go to? It's in the HTML, the page that I'm already on. Okay, so I'm looking at this page. It came to me from Google. It has a URL that's embedded in this number 2, and they chose what link they want. They can put any link there that they want. Okay, so what Google is going to do is they're going to say, he's searching for CF Montreal. I'm going to put that in the link of like basically anything I might click on this website. It's going to be in that link, in that URL. Okay, then when I receive that URL, I don't have to remember what he was searching for. It's in the URL. I just look at it. It says he was searching for CF Montreal, so I know that. Okay, so if I copy this link and then I paste it without going there, you can see like the query is here already. Okay, so I can click on this and it knows to take me to the second page just by reading the URL. It didn't remember anything about me. It just read the URL. Okay, so even if I go to a brand new window or browser, so here's private browsing, okay, my cookies are all reset. It doesn't know anything. It doesn't know that I was the person that was just searching CF Montreal, and I put that link in, it takes me directly to the search results for CF Montreal, okay, because it's all in the URL itself. Does that make sense? Okay, so you can put state in the URL, then the website doesn't have to remember the state, and if it doesn't have to remember the state, then it's a lighter weight website for it. It does require engineering, so every time they give you links, they have to rewrite the links. So the links are now more complicated because every link on a website has all this state that's at the end of the URL. Okay, so anyway, that's why you see like big long URLs now with, and if you look at it, it's usually a pretty simple URL, and then it has this like question mark, and then it has a whole bunch of terms on the end. Okay, so let's assume that browsers work the way they work in terms of cookies. They work in such a way that they let you do cross-site requests. This is good. We want to have a Facebook like button on CBC, and we don't want CBC to know anything about Facebook, right? We'll just let Facebook, or know anything about you and your friends on Facebook. Okay, so cross-site requests are good. RESTful is good because it lets us implement websites that are lighter weight. We don't have to store so much stuff, okay? But let's put the two together. What happens? Okay, so this is a scenario of something that can happen. So let's just take it step by step. I send you an email, spam or like phishing or something like that, and I basically get you onto my website. Okay, I don't tell you it's a fake banking website or anything like that. I just have to get you on my website, period. Okay, so I don't care how I do it. I might say I'll give you $1 million, or here's some like, I don't know, hacked versions of games that you can install and you don't have to pay the license fee. And I might actually give you the game for real, okay? But I'm a malicious website as well, all right? So I get you onto my website, okay? Now, when you're on my website, I can run whatever JavaScript I want, or I can ask for any image that I want. And not just from my own domain, I can ask it from anywhere on the web, okay? So I can tell you, oh, you're looking at my website, that's fine. Go over to Facebook and grab this thing, right? And pull it back into the website. I don't actually see you go out to Facebook. I don't see necessarily what comes back. With JavaScript, I can maybe see what comes back, but that's an added complexity that we'll talk about next class. So I don't see what comes back. I just know that you went to Facebook and Facebook sent you something back. And now when you're looking at your browser, you're seeing the website weave together with my content and Facebook's content side by side. Okay? When you go to Facebook, you send your cookie, and Facebook says, I know who you are. Okay? So it says, I know that it's you, and that's what a cross-site request is. And because I know it's you, you can click the like button, and I'll actually change your profile, or I'll show you how many of your friends like the article, whatever the case is. Okay? Now, imagine instead of sending you to Facebook, I send you to your bank. And if the bank is implementing a RESTful architecture, let's say I'm filling out like a form, and I'm like, I want to send money from my account to your account. This is the amount of money I want to send it. And then I hit submit, right? How does the website learn that I want to do that? Well, what it will do is it will put it in the URL, and then it will just send that URL. Right? And then the bank will just look at the URL and say, well, the URL is telling me to transfer money from this account to this account. Okay? So that's how RESTful works. Okay? So what you could do is you could conceivably, depending on how the bank website was implemented, and many of them were implemented this way, is any action that the user might take, they don't remember, did you come to the website and log in, and now you were looking at your account summary, and now you want to transfer. They don't have that full history because they're not keeping state anymore. They're just seeing a URL for the first time that says transfer from here to here, and they're going to do that transfer because they don't have any state. They don't know that this doesn't look weird to them that you would jump from 0 directly to this URL. Okay? To the bank, they're not remembering anything about you. It's just you're coming, you have the right cookie, and you're asking for this action. That's exactly what would happen if you actually logged into your bank and you did this transfer. Okay? So then your bank will do the transfer. Okay? And then now your money's gone. So all you have to do is you have to go on a different website. You don't have to do anything. You just load it, and then all of a sudden, I don't know, the website starts posting stuff on your Facebook wall. You go back to your Facebook wall, and it's full of ads, right? And people are like, oh, I got hacked. Someone stole my password. No, probably not. Like you probably got cross-site. It won't work now on Facebook because there's protections against it. But that's what would happen like maybe 10 years ago. Okay? So whose problem is this? Okay, this is the bank's problem. It's the bank's problem because they're allowing cross-site requests, and they're using cookies, and they're using cookies for session IDs. And so because they're combining these two technologies and the way that browsers work, and the fact that even though I'm on evil.com, my browser's tossing in the cookie for bank.com, you put all of that stuff together and boom, you have an attack. Okay? So these attacks were like pretty prominent. I would say cross-site scripting came first. So there's a big wave of cross-site scripting attacks, and we'll talk about those next class. And then the second wave was this attack. Okay? So lots of different attacks along these lines. How do we fix this? Any ideas? Okay, what's a verification token? And stick it here? Okay, so we can already assume that this is validated. You look like you're still thinking about it, so I'm going to let you think about it. You're actually on exactly the right path. So you've probably seen the solution, but maybe you can't articulate exactly what it is. Yeah, so my cookie is in the header currently, but do you want to do something else with it? Sorry, say it louder. So I'm already logged in, so I passed that authentication step. So I'm already switched over to cookies. So. Okay, so the solution is actually I take this exact cookie value and that's what I put in the URL. Okay, now why does this work? Okay, so if I'm on the real bank, does the real bank know my cookie value? I'm on the real bank website. Does the bank know my cookie value? They do, because every time I go to them, I send this 55 and they go in my database and they check that my SSID is somewhere in their database. Okay? So the real bank does know my cookie number. Okay? It's here. That's how they track me. Right? Could the real bank, when they use this RESTful architecture, if I'm on the bank's website, it's going to put all the actions into all the links that's on the website. Could it throw my cookie value on the end? It could do that, okay? And then let's say that when it comes back to the bank, can it check whether my cookie value that's here matches my cookie value that's here, matches my cookie value that's in the database, that all three are consistent? It can do that check. Okay, so the bank will basically say, I'll do this transfer, but I want to see a cookie value here that is the same as the cookie value here, that's the same as the cookie value here. Okay, if I see it's consistent there, then that's fine. I'll let the transfer go through. Okay, now why does the attack break? Okay, does evil.com know your cookie value? They don't. If they knew your cookie value, they could just session hijack you right away. They don't have to do anything fancy. They can just log directly in as you, okay? Evil.com does not know your cookie value. Can evil.com get you to go to bank.com and have your cookie value appear here in the header? Yes, it can do that, right? That's the one thing it can do because your browser is going to put it there anyways, okay? Can evil.com send you to this URL and request this resource with your cookie value at the end of the URL? Okay, if it could do that, then what does it know? It knows your cookie value, it knows your session ID. If it knows your cookie value, it could just hijack you anyways. Okay, so evil.com is the one that's writing this URL. It's telling you to go to bank.com and go to this specific URL. If it doesn't know your cookie value, it can't put it on the end of the URL. Okay, your browser will put the cookie in the header, but evil.com doesn't know your cookie value, so it can't put it on the end. But when you go to the bank does know it, and it can put it on the end. In other words, you can have URLs that only the bank can construct, right? That are different than the URLs that everyone else can construct, even if I know how the bank is constructing their URLs. I know what a URL looks like. I know all the parameters that are there. I'm just missing that one value because I don't know your cookie value. Okay? So it's a way that banks can sort of authenticate their own URLs. Like, that was a URL I gave you. I know I gave it to you because there's a secret that's in the URL itself that only I know and you know. We're the only two people that know that secret. Okay? So it's a way of validating URLs or authenticating the URL itself. Then you can use RESTful architecture and it works fine. Okay, does that make sense? Okay. Okay, so in summary, cookies are good. They keep you logged into websites. You're not typing your password all the time. It lets you personalize the website. It remembers it. It's sticky. It lets you do cross-site requests, so you can like an article on Facebook without leaving CBC. The cons are if I can steal your cookie and it's a session cookie, then I can steal your account, I can log in as you. It's not exactly the same as stealing your password because, whoops. If I have your password, I can do anything to your account. I can change your password, all that type of stuff. Most websites are set up that if you have the cookie, there's certain privileged operations that will require you to type the password in again. Okay, so it's maybe not exactly, but again, that's up to the server to implement their backend the way that they want to. It has nothing to do with the browser or the user. The cookies can be used to track you across websites, as we've seen, and it should have a last bullet point, which is that they can lead to cross-site request forgery attacks, which can be prevented, but you have to, it puts extra burden on web developers to make their websites resistant to those attacks.
Like the back website can have some specific policies that there would be some specific websites only that can do the cross-site requests.
Yeah, so the bank policy would be, I ignore any URL that doesn't have a cookie value here that matches what's in my database and matches what the user's sending me here. Yeah, and then that completely kills. It's complicated. I know, like you see it for 30 seconds. It's hard to see why this works, but that, I assure you, that completely kills cross-site request forgeries. Was that your question, or was it different?
So I was saying that what if evil.com is not able to put this, like to redirect the request?
Okay, so another policy is the browsers, Netscape back in the 90s could just say, hey, we're not gonna throw, if you type in www.bank.com and press enter, we'll throw the cookie in. But if you're on some other website and they're loading resources, that's fine. You can load the resources. We're just not going to throw the cookies in. Okay? That could have been the policy. And if that were the policy, this attack would never have emerged. But if that were the policy, then you couldn't do this either. So Facebook couldn't put their like button on it.
Specific websites only would be allowed to do like cross-sites.
Okay, so first off, evil.com can say, I'm happy to cross-site requests with any website, okay? So that kind of policy would have to be implemented on the other website type of thing, okay? So could Facebook say, you know what, if you ever see this like kind of website that's weaved together, we're not the main website you're going to, we're the secondary resources that are loaded. We only want those cookies thrown in if the primary website is one of this websites on a list of websites. Yeah? So you could do that kind of thing. I'd have to look up whether you can implement that exact policy, but now the web has changed a bit and there are these like content policies that you're allowed to add. Most browsers now enforce them. And so you are able to do that kind of fine-grained permissioning, that type of thing anyways. And so there might be a way through, what is it called? CSF, I think, Content Security Protection, CSP. There's a name for the standard of how to do it. So there might be a way out of this attack using those things as well. Yeah.
So like we need to do it on our end, not the
Yeah, so
website will not do it.
exactly. The website won't do it automatically. Your browser won't do it automatically. Facebook itself would have to do it automatically. But then it would also limit, like if I want to grab the like buttons, put it on my page, then it might not work, right? So most websites, actually probably all of them, are going to choose to do this instead of that. But it might be possible to get that content security to do that exact rule. I'm not sure exactly, but yeah. That would be another potential path that would work. Yes? Okay, so what's the whole threat model with extensions first? Extensions basically are allowed to, well, also when you install extensions, you can set permissions, okay? But by default, if you just sort of let it do whatever it wants, every time you're on a website, the extension can insert stuff into the website, anything it wants. It could insert new content, it could insert JavaScript, And then the JavaScript could run and it could do other stuff to it. Extensions do not see cookies, I think. They're like, yeah, I have to, whoops. Maybe they do. Like Ghostry, for example, is an extension. It can obviously see cookies. So I'm not exactly sure how that happens, if it's an extra permission that they need. Yeah, so maybe I should be careful. I'm not exactly sure whether extensions can see cookies by default, if they can see it only on certain circumstances where they get a special permission, or if they can't see them at all. I think it's probably the first or second case, but I'm not sure. So if you have a malicious extension and it can see the cookies, then obviously, yeah, it can session hijack you. So that's a big threat. That's why I think that probably it can't see them by default, but you can maybe give them permission to see it. Actually, you all installed Ghostry, so does anyone remember seeing, it must have asked you about permissions. Okay, so anyways, I haven't installed it myself in a while, so I don't remember what its dialogue looks like. But short of it seeing its cookies, it can still insert JavaScript, and that's super dangerous as well. So getting a malicious extension is one of the worst things that you want to do.
Extensions gives the relevant information, whatever we are searching it on any of the website, it gives the relevant ads on it. So
Yeah, so it.
Trackers might be unable to see the cookies. Might be.
Yeah. So it can definitely ask the browser what website is the user looking at, so it can track you. It can insert JavaScript, so it can insert ads or whatever. And then whether it can see, like the cookies don't get added until the request is past the cookie jar, right? So JavaScript can create the request. Sorry, the extension can create the requests. Then it gets passed to the cookie jar. The cookie jar either puts cookies in or not, but I think the extension loses its ability to see it past that. And in fact, now that I think about it, actually it doesn't matter. So like if the extension can see the cookie jar, it's just as good as seeing, like it can figure out what's going to get put it on the end anyways, right? So if you can see the cookie jar and or see the request on the far side of the cookie jar, they're equivalent in terms of it. So yeah, I don't know the answer to whether extensions can see that or not, but it's dangerous, and malicious extensions can do a lot of other bad things. Yeah, whether or not they can see your cookies. Okay, other questions or comments? Okay, good. So I'll see you all next week.